This begins our study of 2.13 Module Basics from Zybooks. In order to work with the modules, if we're going to work in Zybooks, it's pretty straightforward because they're going to show us exactly what to do here. But at some point, we're going to need to be able to make files like this. So I could make this file. Let's go up here and put in exactly what's here. Control C, Control V. Then I'm going to save it. File, Save As. I need a folder. I've got 121 on my computer. I'm going to put it in Programming Projects. You might make a new folder called Programming Projects. Make some files here for some folders here for yourself. I've got this in Programming Projects, and I actually want instead of text, I want this to have a different extension, because I really want it to be a Python file. They'll look like this if they're a Python file. So I already have this named. They suggest print_name.py, and that's what you'll want to name it. So if you're working with a text file, that's how you're going to name your file. So you hit save, and I want to save it because I already had it saved there. So now I have this file. It's called printname.py. To run this file, there's a couple of ways I can do it, but to run it, I could go to the command prompt, and I'll type on here down and type here to search. I'll type command, and I want the command prompt here. Now I've bumped up my font a bit for this. Let me show you how to do that because it's kind of, you can go to Properties. Actually, it was default in font, and you can change your font so it's a little bit bigger. Now, if I type Python here, if I've got Python actually installed on my computer, then it's going to open prompts for me so that I can type Python code in here. On our course modules, down at the very bottom of the Test 1 assignments, I put this Getting Started with IDLE. So if you're in a hurry to get started with this, you don't have to use command prompts yet. I'm just going to start showing you how to do it. But by the end of Test 1, after you're finished with Test 1 on September 11th, you should have this installed before you begin working on Chapter 4, because I'll be working in there exclusively. I'll keep showing you how to do that, but this Getting Started with IDLE in Python, there's a download for Windows or Mac. I show you how to get to your IDLE, and we're about to do that here too. On Mac, it's a little bit different. There's an app. So this video here shows you a little better how that works on a Mac. The Windows here is relevant for both Mac and for PC. I had to listen to this at almost double the speed because the guy was talking very slowly, but you could just listen to it at regular speed and go through. He shows you exactly how to work with IDLE, and I'm going to kind of work with IDLE a little bit today so you'll be able to see it. But I'm expecting that you'll have these done after the first test. I'm talking to you about it now because we're going to be working with modules right now, so it's about how do you work in and out of the modules. We don't need to actually do that yet, but I'm going to go ahead and talk about it. All right, so if I go back to my command prompt, I've got a prompt in here, and then in here I can just type code, 3 plus 2. I can type print hello world. Oops, make sure to have the right. I hit enter, execute the Python code just as it was. The one line of code said print hello world, and it did. So this is basically how we had to do any of our coding back in the 80s, the 1980s. And since then we have integrated development environments, and what I've asked you to do on Getting Started with IDLE here is to actually download that integrated development environment. So instead, I can go to my Start here, find Python. There it is. I want to start the IDLE here. So I want to first pin it to my Start menu. So it pinned it there. And then I'm going to open it up. It'll open up a window like this. That's a development environment, very much like the command window, but it's got a lot more functionality than that command window. So I showed you the command window, the command prompt, but I'm not actually going to use that again. So it's good to know that, because there are some professors on campus in some of the sciences that when you go to program for them, they will want you to use that command window, which is fine, but this works just fine too. So this Python shell, I'm going to go ahead and pin down. You can see down here, I'm going to right click, I'm going to pin it to my taskbar so that it's always there. And I want it over here so that I can always find it. So you can pin it into the taskbar, and then you'll always have it so that you can open it up pretty easily in any time during class. Okay, so the Python shell here, I can type exactly like I did on the command prompt. It looks a lot like it, right? So I'll just type print hi. You see it works the same way as the command prompt did. So going back to my module basics, I just saved the print name.py. So if I go back to my Python IDE, this is called idle. If I go back to idle, then I can open that file open. Since I saved that, I'm going to go to 121, and my programming projects or files is where I put it, and the print name that I had is right there. So I can open this up, and it opens up a file, and I'm able to see this. Now in here you can change, you can edit, you can do your format, you can run, you can do options, you can configure IDLE, so you can change the font you're using. I recommend you stay with a Courier New, because that is a monospaced font, and it gives everything lined up. You can see how these lines up. So that's the best thing to do for programming. And then if you want to, you can change what things are highlighted, how those are highlighted. So if you prefer different colors in the highlighting that they're doing, like the print statements here, this is a method, print is method, then it's going to highlight that purple, and a string is highlighted green. So you could change that, but I recommend that you stick with it as it is right now. You can always go back to Idle Classic. So you can build yourself a theme, all kinds of things. You can get really fancy. I think you can actually use a dark background too, so you can do that too. I'm going to cancel out of here. I changed my font so that you'd be able to see it, and I'd be able to see it, which is very helpful to me. So if I want to run this, I'll do run module, and it's going to run that file. Now notice that it actually goes to the directory where that file was. I saved it in this directory, and that's cool to know, because now I can put that in my command prompt and run this file from my command prompt. All right, so that's a basic, by the way, that's how idle is going to work, but we're going to be working in chapter 2, the rest of chapter 2, just working in here. And I'll go back and forth to idle a little bit so that you can see how this thing is going to work just a little bit better. So if you have Python code, you can save whatever your code is to a file, open up a text editor, you can save it. That's the basic, simple way to do it. Or you can work in idle and save it as a file. The next part of this is talking about modules. And a module is a file containing Python code. So we just made a module because it contained Python code. So we can import that module. Here they're suggesting that we save 2 separate files. And I've done this module in my directory so I can show you what I did. So I saved these 2 files in section 2.1.3. Notice that these have a little Python icon there, which tells me that their type is Python file. I can actually see what they are. If I do right click and look at properties, this shows me that this is a .py file. I don't need to do anything else in here, but you can see it's a .py and the extension is not a .text. So I could open this in, I could open with idle. So I can edit with idle, or I can open with Word, with Notepad. Right now, I know you have Notepad. So this file opened up, and it just has these 2 things in it. It's called names.py. I'll open this one too. Open with Notepad. This one has this information in it. So looking at these 2 files, I don't need this anymore, so let's move that. Looking at these 2 files, I have a print name.py and I have a names.py. The import statement here is important because it's going to actually open this file and read it, and then go ahead and do the rest of this code. So first thing, it's looking for this. It has to be in the same file folder, and mine are. Names and print name are both in section 2.13, which is where I put it in. You can call them anything. So when I run this code, it will import this and then do that. Now I can't run it from Notepad because Notepad doesn't have a .py. Although I think there's a Notepad++ that may have the Python interpreter in it, but I'm not sure it does. So I'm going to open these with idle and run them from there. So same thing. I'm going to open edit with idle. And I really didn't have to open this one because I'm not changing anything. But note that now the string is highlighted and it's a little bit easier to see what the code is actually saying. Edit with idle. So I've got both of these open so I can see what they're doing with idle. Now this code, if I run this one, run module, it's not going to look very interesting because there's no code there that prints. So it just ran the two and it stored these two into objects. So it assigned Larry to first and David to last. But if I run this other one, and when I run, notice the equals restart here. That means that it's not paying attention to anything I did before. So now if I run this one, it's going to start over. It's going to give me a restart. And it's going to give me a trace back here because I used something that I should not have. If you looked on the original here, it said import names. You can't put the .py there. Names is just the name of the file. You don't want to put .py there, .py there. That's understood. So I need to take this .py off here. We'll save it. You can either do a file save or you can do a Control S. And I tend to do the shortcuts, Control S, and then I'm going to run it again. Run module. And now I restarted and it's doing exactly what I expected to do. It said import the names. So I've got the names as the first and last from the first file, which look like this. So I had Larry and David. And now from the names file, names dot says I'm going to go to the names file and get the first from there and go to the names file and get the last from there. So this is this dot notation is an important way to get the attributes in this case, or the fields, from this particular file. That's what they would be called in Java. In Python, basically you're just getting some of the information from the file. So at this point, all you really need to know is that if you're going to use another file, you're going to have to import it. You do not put the .py. When you run this, and you can start this and run it, you can see exactly how it's going to run. The names dot, this dot notation, is pretty important. If I was using a file named universe that had a speed of light in it stored, and this is a variable, speed of light, you're getting the variable out of there, you use universe dot speed of light. So I'm going to universe and getting. That's how I'm thinking of this dot notation. In 2.13.1, we're talking about this special built-in function with the underscores, 2 underscores name, 2 more underscores. This is a special built-in function for Python. And the main here, with quotes around it, is special to Python. The quote after it. The colon after it. When you put this line of code in, and if you indent, that means that you're doing in a block underneath here. This is way more than you need, but they're trying to first talk about here the name and the main as important functions. If you have this equal to the main, that it means that it executed as a script and it was not an imported file. Notice this is not any imported files in here. The hashtag here tells you where this came from. So it's pretty cool oftentimes when you're putting together a file that you would put a hashtag in there and say what the file name is and the module that it's coming from. They do ask you some questions about what happens if you're using this if statement with the name and the main, but I will not ask you this on the next test unless it shows up in Chapter 3. A lot of the CS 121 students are math majors or math business or math secondary ed or middle. So it's pretty important to understand how to work with math in there. There's a module called math, the math module, that you can import. So if you're going to use any of its functions like square root, so the module is math dot the square root function, and then you can take the square root of the number. So you now have this module that you can use anytime you want to. It's now fair game because you have had it introduced to you. Now I keep calling things like square root a method here, but in Python these are really known as functions. They're also methods, but Python, the typical thing to call them is a function. So I'm using the square root function from the math module to determine the square root of a number. In 2.14.1, they're using a couple of these functions. Here, the math.pal, it's the base raised to the power is how you should think of this, just like you would. So 2 to the 10th is what this would be up here. Math.pal, 2 to the 10th. There are other ways to do this in Python, but this is one way using the math.pal. 2.14.1 is an incredibly good list of particular ones that you want to know. Like pi here is given as a math.pi. You've seen it before, but oftentimes they just said pi was equal to something. Pi is not a reserved word, but math.pi is. The ceiling function rounds up. The floor function truncates or rounds down. And of course we looked at the math.pal already. Square root we know. Factorial, remember, would be if I had the factorial of 10, it would be 10 times 9 times 8 times 7 times 6 times 5. It's sort of, instead of using the format statement, you could do some rounding, and it'd only output 2 decimal places here. So in this activity, this is playing with some of the math functions. Note the math import here. Import math is importing the math module so that you can use the functions that are included with that module. 2.14.3 actually gives you the formula for getting the distance between 2 points. So you want to program that in here. 2.15 is about printing out in a particular format. You don't have to call your values your value. 1, your value. 2, you can call them anything you want to. But if you're going to use this statement exactly as it is, that's what you'll do. So read this carefully. 2.16 is an exercise in using the math.pal. You see you're going to have a function that's raised to a power. So just be careful how you're doing this. It does give you the formula, f0 times r to the n, with n being 1, 2, 3, and 4. So you're going to put several lines in here. They want you to put for n equals 1, 2, 3, and 4. 1, 2, 3, 4, 5 here. So the original was there, the original value, and then raised to the first, the second, the third, and the fourth. So that's what they're expecting. Of course, they have an input that their suggestion you put in. You go down here, we see that there is an input that I would need to put in, so I could put that in. They said 440, so I put 440 in to try this program to see that it works. I won't test you on the information in 2.17, but I do want you to have the exposure to it, which is why I've assigned it. So Unicode here is the basic code anywhere you find, even in HTML, anywhere you find any programming language. This is a universal code for particular characters that you're going to see. So I would think that the characters would start at 0, 1, 2, 3, 4, 5, 6, but actually those are stored in, the Unicode is 48 for 0, 57 for 9. Notice that the alphabetic, the characters that we're used to are letters. The first one is capital A, is stored in 65. So if you're trying to figure out which one is a smaller thing, the smaller would be a 0, and then the capital A would be a little bit bigger than a 0, and the lowercase a is a bigger thing than the capital case A. So if you're trying to find lexicographical order, which is what it's called, the Unicode that you're looking at would tell you which one came first. However, I did say you're not responsible for this. I just wanted you to get a little exposure to it. If you're interested in more, look in Wikipedia under Unicode, and they talk a little bit more about the history of this code. In 2.17.2, they talk about common escape sequences, and notice that here, if I'm using a single quote in single quotes, and I think I said this wrong in the last class, if I'm using single quotes, I'm going to need an escape character. However, if I use a double quote in here, then I wouldn't need one for a double quote if I'm within a string of single. Here I've got double quotes. I need a double quote escape character if I want to put in double quotes around hello friend. If I want to go to the new line, I have the \n, and the tab does an indent. I think the indent is set for 4 for 4 spaces for Python. So those are a little clever little common escape sequences you're going to need to know about. I will expect you to know about these. Now you could use a raw string here. So escape sequences can be ignored using a raw string. So see the R in front of this? This would ignore all the escape sequences and print it out just like it is. So if you wanted it to ignore anything inside, like these quotes, and print it just as a regular quote, this wouldn't go to a new line for you for sure, but it would print out just a regular quote for you if you put the R in first. So the raw string is this R before the string will print out exactly what's written there. So this is a raw string with the backslash, and it prints it out exactly as it is. I will not require you to know this, but this is playing with the Unicode from above. So if I want to know which Unicode symbol is for a particular value, like capital A, then I could put that in and it tells me what that is in the Unicode code, the universal encryption. This is for one character. So one character put in here, it'll show you what that is. So for instance, if I was going to put ampersand in here, it shows me that that's 38. Down here, they're saying to type in a number. So if I type the number between 0 to 255, because there are 256 encoded characters, encoded values, if I put maybe 138, then it tells me that that's what this would be. Now, some places when you're encoding, you want to know these Unicode characters because you might want to use a fancy character like this box here. Section 2.17.1 gives you a few more exercises to work with print statements here. 2.18 gives you a clever little number game to work with. If I put the number 97 in here and run it, I get 97, 97, 97. In fact, any 2-digit number is going to give me that number repeated. So we got 12. I should get 12, 12, 12. And I do. There's another one given here. So you're supposed to write the code to make a 3-digit, and it tells you the algorithm for it, and the code for 5 digits, and tells you the algorithm. So read it carefully and make sure you're doing the exercise correctly. 2.19 is probably an earlier kind of exercise, but here I've given you this so that you can go back and repractice all of the formatting. Remember that you're putting in placeholders and a dot format and putting the values in that you need to. So it's going to ask the user to prompt the user to enter a food name and store it somewhere so that you can print it out later. So this is kind of a rehash of previous labs, but so it should be fairly simple for you. Note that you will have input in this program, so you do need to put some input in the code. Don't forget about that. That completes what we're doing for the chapter 2. So the next thing we'll look at is chapter 3 at the beginning of next week. So now you're ready to complete chapter 2, and I'm looking forward to seeing those grades popping in.